Have you ever wondered if Jupiter was a failed star? A question that has puzzled astronomers and space enthusiasts alike for decades. Jupiter, the largest planet in our solar system, is a behemoth, dwarfing all other planets in its vicinity. It's so immense that it could fit more than 1,000 Earths inside it. But when we compare Jupiter to our Sun, the gas giant suddenly seems less gigantic. The Sun, a shining star, is more than 1,000 times larger than Jupiter. This stark contrast sparks an intriguing discussion about brown dwarfs, or as they're often called, failed stars. These celestial bodies are larger than gas giants like Jupiter, but smaller than stars like our Sun. Some theories suggest that Jupiter could have been a brown dwarf, a failed star that didn't quite make the cut. This theory poses fascinating questions about the nature of our mysterious giant. So was Jupiter a failed star? Let's journey back in time to its formation to find out. Jupiter's story begins in the early solar system over 4.5 billion years ago. As we delve into the past, we find ourselves at the dawn of our solar system, when the Sun was just a fledgling star surrounded by a swirling disk of gas and dust. This protoplanetary disk, as it's known, was the birthplace of all the planets in our solar system, including our colossal neighbor Jupiter. Jupiter, it's believed, was one of the first planets to form. Its formation process was something of an interstellar marvel. It began with a process called accretion, where dust and rock in the protoplanetary disk began to collide and stick together. Over time, these collisions resulted in larger and larger clumps of matter that eventually formed a solid core. This core, which was likely about 10 times the mass of Earth, had a strong enough gravitational pull to attract the surrounding hydrogen and helium gas, forming a thick gaseous envelope around itself. This is how Jupiter, a gas giant, was born. Now you might be wondering, with such a massive gas envelope, why didn't Jupiter turn into a star? After all, stars are essentially massive balls of hydrogen and helium, just like Jupiter. Well, the answer lies in the mass. For a celestial body to ignite nuclear fusion in its core, the process that powers stars, it needs to be about 80 times more massive than Jupiter. Jupiter, despite its size, simply didn't have enough mass to spark fusion and become a star. It remained a planet, albeit a massive one, in the solar system's family. So, if you've ever gazed up at the night sky and admired Jupiter's bright glow, remember, you're looking at a celestial body that's been around for over 4.5 billion years. It's a gas giant that could have been a star, but didn't quite make it. Instead, it took its place as the largest planet in our solar system, a silent sentinel watching over the lesser celestial bodies orbiting our Sun. And that's how Jupiter, a planet with potential to be a star, came into existence. Now that we know how Jupiter was born, what exactly is it made of? Let's peel back the layers of this giant planet to discover its unique composition and structure. At its most basic, Jupiter is a ball of gas and liquid, predominantly composed of hydrogen and helium, the two lightest elements in the universe. This composition is reminiscent of the Sun, earning Jupiter the nickname of a failed star. But it's not just these two elements that make up Jupiter. Dive deeper into the atmosphere and you'll encounter a layer of metallic hydrogen. This curious state of hydrogen behaves like a metal due to the immense pressure and temperature within Jupiter. This metallic hydrogen extends down to what scientists believe is the planet's core, a hot, dense hub of elements heavier than hydrogen and helium. Though we can't be sure of the core's exact composition, it's thought to contain elements like rock and metal. However, don't let these descriptions fool you into thinking Jupiter has a solid surface. In fact, Jupiter lacks a well-defined solid surface. The transition from the atmosphere to the planet's interior happens gradually, with gases becoming denser as we go deeper. Now let's talk about Jupiter's impressive magnetic field, which is the largest of any planetary body in our solar system. This magnetic field is generated by the rapid rotation of the planet's metallic hydrogen layer, creating a dynamo effect. It's so strong that it even helps form Jupiter's beautiful auroras, akin to our northern and southern lights. And speaking of rotation, Jupiter is the fastest spinning planet in our solar system. A day on Jupiter lasts just under 10 hours. This rapid rotation contributes to its flattened shape and extreme weather, including its famous Great Red Spot, a storm that's been raging for centuries. So, Jupiter is a gas giant with unique characteristics. But what if it was a rocky planet instead? Let's explore this hypothetical scenario in our next segment. Imagine, for a moment, a completely different Jupiter, a Jupiter with a solid rocky surface. This isn't the Jupiter we're familiar with, a swirling mass of gas and storm systems. Instead, consider a Jupiter that's more like Earth, Mars, or Venus, with a surface you could actually walk on. In this alternate reality, Jupiter's gravitational pull would certainly be different. As the largest planet in our solar system, its gravity has a significant influence on the paths of other celestial bodies. A rocky Jupiter might have less mass, altering the orbital paths of its moons and potentially even other planets. And then there's the question of life. Could a rocky Jupiter harbor life? It's tantalizing to imagine, but remember that our Jupiter is far from the Sun, with temperatures plummeting to minus 145 degrees Celsius. As fascinating as it is to imagine, Jupiter as we know it is a gas giant, and it plays a crucial role in our solar system. So, was Jupiter a failed star, and what would happen if it was a rocky planet? We've traversed the cosmic journey together, exploring the birth of Jupiter, its formation, and the fascinating composition that makes it the largest planet in our solar system. We've delved into the intriguing theory of Jupiter being a failed star, a celestial object that couldn't quite muster the mass to ignite into a full-blown star. We've also ventured into the realm of imagination, pondering the scenario of Jupiter as a rocky planet, a different version of Jupiter, complete with a solid surface and perhaps a host to a myriad of geographical features. But irrespective of the theories and hypotheses, the truth remains that Jupiter, with its massive gaseous body and stunningly beautiful storms, is a marvel of the cosmos. Whether a failed star or a successful planet, Jupiter remains a fascinating subject of study, holding many more mysteries for us to uncover.